In the early 1980s, NASA stood on the edge of a new frontier. The Apollo missions were history. Skylab had crashed back to Earth. But in the background, beyond the public's eye, a revolution in spaceflight was heating up. NASA was preparing to launch something entirely different. Not a rocket, not a capsule, but a spaceplane. This was the age of transition, from disposable spacecraft to reusable launch systems. The Space Shuttle wasn't just a new spacecraft. It was the promise of routine access to space. But before that promise could be fulfilled, NASA had to navigate through two of the most defining, overlooked, and technically demanding years in its history, 1980 and 1981. The 1980s began with a bang, Voyager 1's flyby of Saturn in November 1980. It was the mission that gave us the iconic photo, Saturn's rings in crisp, dramatic detail, looking more like art than science. But here's what most people don't know. Voyager 1 almost missed its perfect shot. As it approached Saturn, one of the spacecraft's key instruments, the scan platform, briefly jammed. Engineers back on Earth, over 1 billion kilometers away, had to troubleshoot in real time using a combination of predictive modeling and deep space ping-pong. If they failed, they'd lose a once-in-a-lifetime window to observe the planet's famous hexagonal cloud system and Titan's thick atmosphere. But they didn't fail. Voyager 1 delivered images that stunned scientists and the public alike. It discovered new moons, unexpected ring structures, and confirmed that Titan's thick atmosphere might hold organic chemistry similar to early Earth. Then came Voyager 2, which followed in August 1981 with its own Saturn flyby. Although its trajectory was slightly different, it too revealed jaw-dropping data, particularly about Saturn's magnetic field, which turned out to be shockingly well aligned with the planet's axis, something scientists still scratch their heads over. While Voyager was thrilling the scientific community, down on Earth, NASA engineers were sweating over something much closer to home: the birth of Space Shuttle Columbia. The idea of a reusable spacecraft had been floating around since the 1960s, but designing it was another story entirely. By 1980, Columbia had been assembled, but flight after flight was delayed due to technical issues. One of the biggest setbacks? Thermal protection tiles. Over 24,000 heat-resistant tiles covered Columbia's surface. Each one was uniquely shaped, hand-fitted, and crucial to preventing the shuttle from burning up during re-entry. But the tiles kept falling off. Literally. There's a story, told among shuttle engineers, about an entire day spent reattaching just 4 tiles. They'd bond one, run tests, and it would fall off during vibration simulations. Every test failure delayed the program, but the NASA team kept pushing. It was slow, frustrating work, but it was essential. In the meantime, Columbia underwent fit-check missions, where the orbiter was mounted atop a Boeing 747 shuttle carrier aircraft and flown around the country. The public would see it soaring piggyback through the sky, unaware that under the surface, Columbia wasn't quite ready to fly. While all eyes were on the shuttle, NASA's Earth science missions continued to produce critical, if quieter, breakthroughs. One such mission was Nimbus 7, launched in 1978, but fully operational and producing data in the early 80s. Nimbus 7's instruments measured ozone concentrations, ocean color, and atmospheric aerosols. The satellite's data would later help scientists confirm the presence of the ozone hole over Antarctica, one of the most significant environmental discoveries of the 20th century. Another key player? Landsat 3, still orbiting Earth, provided detailed surface imaging that helped track deforestation, crop health, and urban expansion. These satellites didn't have the glamour of planetary missions, but they became foundational for modern climate science. Despite these advances, NASA's budget was under constant scrutiny. Public enthusiasm had waned since the moon landings. Politicians questioned the need for continued investment in space when domestic issues loomed large. In 1980, President Jimmy Carter's administration showed support for science missions, but the shuttle's cost overruns created tension. When Ronald Reagan entered office in January 1981, his administration brought a different tone, one that supported space exploration, but emphasized cost-effectiveness and return on investment. NASA's leaders knew that Columbia's success would either secure or jeopardize the agency's future.
We've gone for main engine start.
On April 12, 1981, everything changed. After years of setbacks, Columbia launched on STS-1, the first orbital flight of the Space Shuttle program. Astronauts John Young and Robert Crippen were strapped into an untested spacecraft, sitting atop two solid rocket boosters, a configuration that had never been tried with humans before. It was arguably the riskiest crewed mission since Apollo 11. Columbia thundered into orbit flawlessly. And after 54 hours in space, it re-entered Earth's atmosphere, gliding back like a plane, landing safely at Edwards Air Force Base. It was a technical and symbolic triumph, but not without its quirks. During re-entry, the heat tiles performed brilliantly, but one tile on the bottom had indeed come loose. Luckily, the missing tile was located over a reinforced carbon-carbon panel, preventing catastrophe. If it had dislodged in a more vulnerable area, the mission might have ended in disaster. NASA got lucky, and they knew it. Still, STS-1 validated the entire shuttle concept. It proved that spaceflight could become more routine, more flexible, and more reusable. Here's a little anecdote most people don't know. Aboard STS-1, tucked into Columbia's middeck, was a secret payload, a small data recorder nicknamed Mr. Bill. Inspired by the Saturday Night Live Clay character famous for yelling, "Oh no!" NASA engineers had added the figurine as a gag, but also as a vibration test subject. When they recovered Mr. Bill after the flight, he was slightly cracked, giving engineers insight into how stress transferred through the orbiter. It was a funny, human moment in the middle of a high-stakes mission. Following STS-1, the momentum picked up. STS-2 launched in November 1981, this time carrying more scientific payloads and continuing the effort to test reusability. Young and Crippen had returned heroes, and now new shuttle crews were training. One of the underreported moments from STS-2, the shuttle's robotic arm, known as the Canadarm, was tested in orbit for the first time. This Canadian-built appendage would go on to become a staple of shuttle operations and critical for building the International Space Station decades later. There was also a subtle political undertone. Columbia's successful flights gave the United States a visible win in the ongoing Cold War space race, as the Soviet Union's own reusable shuttle program, Buran, remained in development. Behind closed doors, the Pentagon had taken a serious interest in the shuttle program. The Department of Defense believed the shuttle could give the United States an edge in deploying reconnaissance satellites or performing rapid orbital missions. In 1981, before Columbia's maiden flight, NASA quietly began modifying shuttle infrastructure to support military launches. Vandenberg Air Force Base in California was upgraded with shuttle-specific launch pads, intended to allow polar orbit launches, ideal for surveillance missions. NASA's civil space program and the United States military were intertwined in ways that would shape shuttle design, flight trajectories, and mission secrecy for years to come. Most of this wasn't visible to the public, but it was happening right alongside the countdown to Columbia's first real flight. By the close of 1981, NASA had successfully flown 2 space shuttle missions, opened new doors in robotic planetary science, and continued Earth monitoring efforts that would pay off years later. But perhaps more importantly, NASA had proven it could evolve. It wasn't just a moon agency anymore. It was a systems agency, managing reusable spacecraft, long-term science missions, data satellites, and public-private partnerships. The shuttle program was off the ground, and a new kind of space age had begun. 1980 and 1981 were not just stepping stones, they were crucibles. They tested NASA's patience, engineering, budget, and vision. But from those trials came one of the most recognizable symbols in human space history, the Space Shuttle. It launched like a rocket, landed like a plane, and captured the imagination of a new generation. And while Columbia was just getting started, NASA knew that the road ahead would be both brilliant and perilous. But for now, they had pulled off the impossible again. If you enjoyed this narrative, make sure to like this video and subscribe to our channel at Beyond Earth Buckle Up for more fascinating NASA history narratives. Remember to take care of one another, and always keep looking up.